Yo, what is up, guys? Welcome back. Episode 160 today. Today's my birthday. Turned 24 today. Pretty excited about that. It was a good day overall. But yeah, we can't make any excuses. I didn't hit the gym this morning. I was a little bit too tired, man. I don't know. I'm kind of sad I didn't hit the gym, but sometimes it'd be like that. We're going to hit the gym tomorrow morning, and we're going to do a video today. Make no excuses, keep going. So, let's take a look at some problems today. Also not feeling the best, too. Kind of a stomach ache all day. Let's jump in and check. Take a look at that ELO website. Right here we were looking at problems 1500 to 1600. Oh shit. Oops. 1500 to 1600. Let's go to page 12. Large values from labels did yesterday. Minimum length of string after leading similar ends. Galactic, bro, what's up, man? How you doing, dude? Good to see you every day, bro. How was your day today? Take a look at this problem. Let's take a look here. Minimum length. Let's pull this up, dude. Oh, whoops. Whoops. How do we do this? Oh. Oh, we got it open here. Setting up our environment. Happy birthday, Max. Thank you, bro. Appreciate it, dude. Thank you, Galactic. It's been a good day. Been kind of hella tired, dude. Hella tired. My stomach hurt, but it's been a good day, though. I feel like it's all probably the food I've been eating. Well, yeah, let's take a look at this problem. 1500 level rated problem. Minimum length of string after leading similar ends. So, given a string S consisting of only characters A, B, and C, you're asked to apply the following algorithm on the string any number of times. Pick a non-empty prefix from the string S where all characters in the prefix are equal. How was your day today, Galactic, bro? Was it good, man? You chilling? Okay, so pick a non-empty suffix from the string S. The prefix and the suffix should not intersect at any index. The characters from the prefix and suffix must be the same. Delete both the prefix and the suffix. Return the minimum length of S after performing the above operation any number of times, possibly 0 times. Yeah, a bit tired though. Same with me, bro. Same with me. The prefix and the suffix should not intersect at any index. Let's see. Let's get an example here. An optimal sequence of the operations is take prefix C and suffix C. Okay. Take prefix A and suffix A. Okay. B and B. Okay. A, take prefix A and A and remove them. S is equal to this. Output is 0. Okay. Trying to like fully understand this problem, what we have to do here. Take prefix AA and a suffix A, remove them, S is equal to B. So we can pick a non-empty prefix from string S where all characters in the prefix are equal. All characters in the prefix are equal. To pick a non-empty suffix from string S where all characters in the suffix are equal. Okay, so do they have to be equal as they go? They have to be like a palindrome sort of thing? So we can only go A here, take A here. Oh, take prefix AA, take prefix A. Then we can take prefix B and prefix BB and remove them, and we're left with S is equal to CCA. I feel like that's a good... That's a good input here, right? Prefix and suffix should not intersect at any index. The characters from the prefix and suffix must be the same. Delete both the prefix and the suffix. So really, my first thing that I'm thinking about this problem, yo, what's up, Ethan? Good to see you, bro. Really, the first thing I think about in this problem is... I think about probably a two-pointer solution, right? That's the first thing that comes to my mind. Obviously, we have 2 pointers, right? One for our prefix, one for our suffix. I assume what we want to do here is we want to compare these 2 values. We compare our first 2 values. Then we either want to move inside one more. I guess, what would be the best way to check this? Trying to think here. I definitely think this is two pointer problem. Pick a non-empty. So this is fine. Should not intersect. And the characters from the prefix and the suffix must be the same. Delete both the prefix and the suffix. So really, I think we compare. We have our 2 pointers, we compare. Right? If they are the same, we move. We can check. Maybe somehow we can check our next value here. Move forward. If they're the same, we leave it there. We check our next value. We see that it's B. We leave it here. Right? We leave our left pointer here. Then we check, okay, is the next value A here? Leave it. It's not the same. So then we would slice our array and take this part here, right? And how would we take this part? Well, when we slice in Python, it's inclusive here, so we'd have to include this part here, but really it's exclusive on the end here, so we'd have to jump and take this part over here. I guess really I should be doing it underneath here, so inclusive here, and then take this part here, which would take this part in theory. And then we repeat, check, keep going, repeat, check, keep going, repeat. Is that the best way to think about it? I got no fucking idea, to be honest. But that is the way that I'm thinking about it. Let's take a look, though. Someone. Okay. So yeah, I think we're gonna go with a 2-pointer solution, right? I'll just write it here on the screen. Go for probably a 2-pointer solution here. That's the intuition. So let's go ahead and do it. I'm trying to think, what is the best way here? I'm thinking... what's the best way to go about this problem, this 2-pointer solution? Probably... I think we need our pointers, right? So let's do left is equal to 0. Right is equal to the length of S minus 1, right? Okay, we'll probably use some while loops, so we can do while left is less than right, right? Because if they do overlap, we don't want to be equal, right? Because if they do overlap, They should not intersect at any index. So I think that pretty much hints to us that we don't use less than or equal to, we use less than the entire time, right? Trying to think here. Really, do we even need to slice? I don't even think we need to slice. I think we're thinking too much about it. Type shit. I think we're maybe thinking too much about it. So instead of when I said to slice from here, maybe really we can just use our pointers to our advantage, right? We can yeah. Use our pointers to our advantage. So really we can start off with while left is less than right and S left is equal to S right. Right, loop through our while loop like this. Kind of blanking here, not gonna lie. While left is less than right and S left is equal to S right. So we would start here, right? I mean, we're comparing this value, right? Okay. We're comparing this value. Right, what do we want to do from here, right? And S left is equal to S right. We want to go to the next value. So these two are equal to each other. So what would we want to do? I guess we'd have to figure out, okay, how can we move our left pointer? And how can we move our right? So, I think we need probably some sort of double while here. While left is less than right and S left is equal to S right. We can do, well, what is the best way to do this double while? I've actually never really thought about a problem using a double while. I was thinking, so we compare our initial values, right? And this is what we're doing here with our while, right? We start off, compare our initial values, far left and far right. We jump inside of the while. And we need to figure out how we can move this pointer all the way over here. And then, in this case, this pointer stays here. But, oh, well, actually, no, actually, this pointer goes across. So, can we compare it to itself? Can we do, well, while... It's tough to think about. It's tough to think about for sure. Maybe we can, inside of our while, we can assign S left is equal to char. So we want to save this value, right? That's really our first step. We want to save the first value that we're looking at inside of our original while, right? Then we can probably do, well, while left is less than right, because we don't want to keep going, right? Again, and S left is equal to char. We can increase our left by 1. And we do the same over here. While left is less than right and S right is equal to char, we increase our value by 1. Right? I think that's the move here. Increase left. Oh, sorry, this is not a plus equal. This would be minus or equal to 1. My bad. Right, and what is this going to do here? Well, think about it. We're not slicing, right? We're not actually slicing the array and making it small. I feel like we could do that. You know, we probably need some sort of helper function to do that. But we're just mainly using our pointers, right? I feel like this is getting kind of messy here with all the pointers, but really what this is going to do is we're going to enter the while loop. We're going to see that these two are equal to each other. We're going to move our left pointer all the way over to B. So now our left pointer is going to be here. We're going to move our right all the way over, right? But in this case here, our right would move here, right? Then what are we going to do now? Well, we're going to do the same thing. While left is S right and S left is equal to S right, which they are, we're going to move inside, right? So assign S left, right? We're going to do while left is S right and S left is equal to char. Well, it is right now. So now we're going to move to here, right? We're going to be at C. This one's going to move to A. I think you mean char is equal to S. Oh, yeah. Yeah, you do. My bad. Sorry. Thank you, Ethan, dude. Char is equal to S left. We move, compare these two. Now in this case here, they're not equal, right? So I would assume, what do we return? We return however many characters are left, right? So our pointers are pointing here. So really, how can we calculate this? Well, if this ends, right? How can we calculate the distance here between these two values? Well, I think from memory, when I think back to sliding window problems, I think, what is it like? I was thinking like left plus right minus 1. Or I don't think it's like that because we do left plus right. We're at what? 3 plus 5 minus 1. Yeah, that doesn't work. Is it? I think it's left minus right. My bad. Left minus right. Or right minus left. Oh my gosh, dude. Tripping balls, dude. Right minus left, right? Right minus left plus 1, right? And in this case here, we would go 0, 1, 2, 3, 4, 5. 5 minus 0, 1, 2, 3. 2, we get 2 here, and then plus 1, which should get us 3. So I think what we can do here is we can return right minus left plus 1. Let's see what this gives us. Okay, we were kind of close. That's probably a good start. Type shit. What do we get here? We outputted 1. So really, what were we meant to do here? We were meant to output 0, but why? Oh, I guess the reason why is because we went past here, right? So we would compare C and C. So let's put this. Let's put this over here. Compare these, what we're looking at, right? Kind of run through our algorithm here. Obviously, we start at CC, right? We would move in, right? Move our values in. We come to here, compare here, move our values in, compare here, move our values in. This is where we kind of check here. We would obviously compare here and compare here, but we would end this loop, right? We would come outside of this while. I think that's why we're adding 1, because really what we're doing here is we're crossing our paths here, and I don't think we have the case to compare that. So how can we do with that though? I don't know. While left is less than or equal to right. Anyone have an idea? Does anyone have an idea about this code? I know I'm on the right track, but I'm not sure kind of how to do with this case. So I think as we're swapping here, we get to these values, we compare, we jump in. Left is still less than right, so we increase left by 1, right? Which in this case, 1 would go to here. Then I don't think it would run this case, right? And then we would probably do right minus left plus 1. That would equal out to be 0, and the plus 1, that's why we're returning 1 here. How can we get past that case? What if we made this less than equal to? If this was less than or equal to, right? It probably wouldn't run again. This would still run. So we would go here, and if we compare our left to our right, I think we'd pass 0. So I think we need an equals here. Let's see what happens if we do an equals. Bro. That was probably easy for people to notice, but dude, I low-key kind of feel a little fire after that, not gonna lie. Like, low-key, like, if this passes, bro. Low-key, I think it's probably because it's my birthday, bro. I feel kind of fired up about that, I'm not gonna lie. Like, 1, the correct intuition. 2, we barely had any issue doing it. Look-key, that was probably a really easy problem for a 1500 level problem. I don't probably think that's probably meant to be 1500, but I feel pretty proud about that. I'm pretty happy about that. Walking through that, seeing that that's what the reason was. I'm pretty impressed with that. So that's fire, bro. That's fire. Type shit. Thank you, Ethan, bro. Type shit. Let's check out. Let's run this in C++. I think this should be a pretty straightforward C++ solution. I think. I don't think we should have too much trouble with this one. Fetch 1750. Type shit. Alright, bro. Let's open our Visual Studio here. What do we look at? This one here. Oh, whoops. How do we move this to the left side of our screen? Whoops. Okay. So the way we kind of thought about this problem was, well, what do we begin with, right? We begin with our pointers, right? We initialize our pointers. Right is equal to, shit, can we do s dot size? Yeah. I'm going to assume that works. I think. I'm going to just assume that works for now. I guess we'll find out a little later. We obviously want our while loop here, right? We started with, well, while left is less than right, and s left is equal to s right. We need our parentheses here. Oh shit, I'm thinking Python, dude. It's not good. Alright, so we had our outside while here. We come inside our while loop here, and we do, okay, well, while, what do we do here? We did while left is less than or equal to right. That was our change there. And, oh shit, we need to create our integer here, int. No, this wouldn't be an int, this would be a char. C is equal to s left, sorry, s left, right? While left is less than or equal to right, and s left is equal to char, so not char, is equal to C. We want to left plus or equal to 1. While right, sorry, while left is less than or equal to right, and s right is equal to char, oh, C, whoops, we want to increase here, right? Why are we getting a error here? I do not know why we identify C as undefined. Are we defining C here? Is my compiler just being stupid here? I don't know. Does anyone know what the issue is here? Really, what do we want to return here? We just want to return, well, right minus left plus 1, right? You guys have any idea what this issue is here with the compiler? Why we're getting... You need to try CC. Yeah, I know that. I tried to change it, but... I'm still getting some errors here. Expected a colon. Oh, we've got our colons here. Is that our issue? Expression must be a modifiable L value. Oh, we need equal here. Okay, there we go. Oh. I'm just gonna kind of run this solution. Probably just put a breakpoint here and just run it from here. You move the char inside the while scope. Oh shit, dude. My bad. I didn't even see that, bro. I guess these throw me off too. I didn't even see that. Thank you for that, bro. Didn't see that. Okay, yeah, that looks good. Let's I think this should work, so I'm not even gonna try and debug it. I guess we're gonna debug it anyway. I did place a breakpoint. Which one are we doing here? Similar ends. Guess we could just step through this. Okay, so I think that did work. Let's step through this. Oh. We returned right away. Why is that? I need to look at that again. Why did we... Similar ends, yeah. Step through this. So our left is 0, which is obviously what we wanted. Our right is 13. Oh no, that's right. Are these the correct test cases here, Ethan, or is this incorrect? Oh shit, I didn't even realize and. Oh shit, it does have the and keyword. Dude, I didn't even see that either. These don't look like these are the right test cases. Right, because if we compare them to... Hang on. If we compare them to Leetcodin's test cases... I mean... I don't know, that seems like something's wrong here. Because really when I'm stepping through this, it's just instantly going out. Doesn't seem like the correct test case, but... Huh. I'll switch these to and here. Just put your C++ code in the C++ solution on Leetcodin. I need to fix that apparently. Okay. Yeah, I'll throw it in and see if it passes. Let's see, let's switch it to C++. Actually, we don't need, I just need these. While here, then the return. Pretty sure this should pass. Nope. It's not passing. Why is it not passing? Oh, shit. Flew over here, dude. What are we missing here? While left is less than right and S left is equal to S right. Put our char. Left plus or equal to 1, right plus or equal to 1. Seems like it's the exact same. Am I missing something here, or... I'm not sure why this is not passing. Does anyone see what we're missing here? I guess we can... While here... This should go over here. Let's go over 1. Anyone see the issue here, dude? I'm not sure. We're expecting 0. What are we getting? We're outputting 8 every single time. While left is less than right. And S left is equal to S right. S dot size. Yeah, dude, I have no idea what the issue is here. What are we... Oh, yeah, that's my issue, Ethan. Yep, I didn't notice that. That is my issue. Whoops. There we go. Little things you don't notice. Let's debug this and see if it passes the test cases now. Actually, let's just remove this breakpoint. Okay, we're still failing the test case here, so I think there is something wrong with this one, Ethan. This problem here. If you want to be optimized by these statements, use right minus right. Yeah. Okay. You are right, yeah. But yeah, we'll take that. We will submit that solution happily. That was a pretty quick problem. I think we'll jump into something else. Take a look at the next one. Find the longest semi-repetitive string. Guess we can take a look at this one. We're giving a string S that consists of digits from 0 to 9. A string called semi-repetitive if there is at most one adjacent pair of the same digit. For example, 0010, 0020. Oh my god, I don't even want to say those numbers. 0020020, 0123, 2002. A semi-repetitive, while the following are not. A string is called semi-repetitive if there is at most one adjacent pair of the same digit. At most one adjacent pair of the same digit. For example, these are semi-repetitive while the following are not. Return the length of the longest semi-competitive substring of S. To be honest, bro, I am not the longest semi-repetitive substring of 5223. Picking the whole string 522 has two adjacent same digit pairs, 22 and 33. 2233. 5494 would just be 4, right? Output 4. I'm a little confused with the problem, not gonna lie. Let's take the whole thing, yes. So we know what we're working with here. I'm definitely gonna ask GPT to explain this problem a little better because I'm a little confused with the description. I don't know how you guys feel, but also my test cases are broken strings. It's passing quotas as quote. Okay, sounds good. Yeah. Fair enough. I was gonna say, what do you guys think about this problem here? I'm thinking the description of this is pretty shit. Not gonna lie, it's a little bit confusing. At least in my opinion. Repetitive substring. I'm gonna see if I can get a better explanation of this. Can you explain this better? No code. You need to find the length of the longest substring where at most one pair of consecutive equal characters exists. This is called semi-repetitive substring. What is a semi-repetitive substring? A substring is semi-repetitive if it has at most one pair of the same character appearing back to back. Oh, okay. I think we're cooking here, bro. Low key. So we're given. I think I understand, right? Any substring in here, right? So really, are we just looking for numbers that are repeated? We're looking for at most. Return the length of the longest semi-repetitive substring of S. If there is, I feel like this is an important definition here in this. I feel like we're going to copy this over. This is definitely important. A little bit of a definition here. A string is called semi-repetitive if there is at most one adjacent pair of the same digit. At most. Here, example 2, we output 4. I'm a little confused why we're outputting 4 here. 5 to 2, valid, only 1, 2 repeated. Not valid, 2 repetitions, 2, 2, and 3, 3. Valid, no repetitions. Valid, only 1 repetition. Not valid. 2 overlapping repetitions. 1, 1, and another 1, 1. Return the length of the longest substring in S that is semi-repetitive. So, I'm not gonna lie. I'm still not fully comprehending the problem, but what I'm kind of feeling here is a little bit of a sliding window, right? We increase. You know, somehow check what we're looking at, right? If we see this, well, this doesn't work, right? So we would move our left pointer here. Well, this works, so that's 1. And that's 2. But I still need to fully, like, grasp the problem, but I'm thinking probably a sliding window here, maybe, as the intuition. If someone in the chat could help me explain this problem, I feel like I struggle a little bit with understanding the problem fully sometimes. 0010, 0123. How is 0123 semi-repetitive? There's not even a repetitive string in here. How is this semi-repetitive? Is this a mistake, you guys think? Or why is it... How is 013 a semi-repetitive string? And how is this not? We literally have 00 right here. Like, and 22. Return the length of the longest semi-repetitive substring of S. I feel like we're returning 4 here, like this. How are we returning 4 here? Like, how does this return 4, bro? I do not understand how this returns 4. Okay, this guy says simple sliding window or 2-pointer problem. Am I still not able to understand what I need to do in this question, dude? I don't understand either. Should really rename this question and problem statement from semi-repetitive to basic or something like that. It's confusing because semi-repetitive is a 0123 is not semi-repetitive in any way, yet it falls under the classification of semi-repetitive because it has less than 2 repeating digit pairs. Oh. Oh. Okay. The restriction is that there must be not more than 1 repeating pair of digits. Okay. So I think I'm understanding now. Maybe. So is this considered... This is not considered semi-repetitive, right? Because we have more than 2. We have 2, 2, and we have 3, 3. So this wouldn't work. The longest semi-repetitive substring is 5, 2, 2, 5, 2, 2, 3. Oh, okay. Picking the whole string has 2 adjacent same digit pairs, 22 and 30, but at most is 1 is allowed. So we would return 4 here. Okay, I understand. Here, we output 4 because it doesn't work here because we can only take at most 1. Okay, I think I'm starting to understand here. Here, we can only do... Well, this would be 1 here. This would be 3. So really, we'd only return 2 here because really only this would work, right? If we have 2 here... We have a repeating 1 here. We can't go anymore, right? Because we add an extra 1. That's considered another substring, right? And we're looking for at most 1. Hey G, just want to let you know that you are better than any Python developer who have jobs. Most of them don't know things that you know. They just got lucky and perfect timing, but I believe you can outrun them. Thank you, CM Evil. That means a lot, bro. Thank you so much, dude. Thank you for that. Thank you for that nice comment, dude. I really appreciate it. Thank you, man. So, okay. I think this makes this problem a little easier, at least in my eyes. My initial intuition here, I think, is what I'm going to keep it at. Is I'm thinking this problem is a sliding window problem. I'm pretty confident that this can either be solved with either a sliding window 1, right? Or, I'm not really sure about this, so I'm going to leave an X here, but I think probably 2 pointers would work here too. C++? No, bro. No C++, man. I'm going to do Python first, bro. I get, like, I don't know. In my head, dude, it's, stop worrying about the syntax. I want to solve it in Python, then I'll transition to C++, but I think what we're going to do here is we're going to tackle this using a sliding window, right? So I think this is a good problem for me for a sliding window because 1, it's been a while since I've implemented a sliding window, and 2, I think it'll be a good refresher. You can do it. Should I just code this in C++, bro? No Python, dude? Type shit? I want to think about my solution first before I get into the code. So really the way we want to think about it here is if we have this example here. Yeah, you can do it. You already did the most difficult problem yesterday. Yeah, that was tough yesterday, bro. Holy shit, dude. That was AIDS, dude. Not gonna lie. Okay, I'll solve it in C++. I'm going to think about this problem first, right? So really we have our left pointer here, right? I mean, when I think about a sliding window, at least I certainly believe in your ability, especially for a problem like this. Okay, all right, I'll do it. I'll do it. So I'm thinking probably a for loop, right? We begin with our left pointer here, right? And our right pointer being here as well, right? First of all, let's think. Well, how does a sliding window work? Dude, this is probably a good refresher for me. We add our first value, right? Being 5, and we would probably move to the next value, right? What would we do here? Well, we'd probably... We have to think about when we're going to move our left pointer, right? And in this case here, we'd probably want to move our left pointer. Or do we even really need to? Do we move our left pointer? If our right doesn't equal our left, I guess we're kind of thinking dynamic sliding window. To be honest, Galactic, I'm not sure what that is, bro. I'm not sure what a dynamic sliding window is, bro. Not gonna lie. Oh, there's 3 types. Okay, I didn't even know this. There's 3 types of sliding windows: fixed, dynamic, dynamic with auxiliary data structure. Most of the medium-ish problems will solve first and 2. Oh my gosh, dude, this is a 36-minute video, dude. Jeez, man, that's crazy. Here, let's just let's think. Dynamic sliding window versus fixed sliding window. Ethan says, if the duplicate count is greater than 1, you shrink the window by moving the left forward until it's valid. If the duplicate count is greater than 1. Okay. Let's just take a look at the difference here. The key difference between a dynamic and a fixed sliding window lies in how the window is managed. A fixed sliding window maintains... Basically means you adjust the window size dynamically rather than setting the window fixed. Okay. Right. Okay. A fixed sliding window maintains a constant window size throughout the process, while a dynamic sliding window adjusts its size based on... Okay, that's what Galactic said. Okay. The window size remains fixed, determined by the problem requirements, e.g. the finding the maximum sum of subarray of size k. Okay, I do remember solving that problem, so that is a good comparison here. The window size can expand or contract based on conditions or rules defined by the problem. It's not always linear. Okay, so we've confirmed that this is probably a sliding window problem, right? So Ethan said earlier, if the duplicate, you'll need to track how many adjacent equal digit pairs are inside the window. That's the duplicate count. Okay, so I think I understand what you're saying, right? So we have our count, right? Which is initially 0, right? We have our left pointer. So really, we're going to move our left pointer if our duplicate count is greater than 1. Right, so... Maybe we can maintain some sort of... Play some music again? Yeah, shit, dude. I probably should, low-key. I always forget. Dude, low-key, am I gonna get a copyright strike if I actually play, like, other music? I have no idea, dude. Like, fucking, it's right. I'll just play lo-fi. Lo-fi's pretty fire anyway.
My work is easy because I use ClickUp. Here's how I keep track of all my tasks. I start by brain dumping everything I need to get done in a...
Is it like good volume? Is this good? Or you might. Oh, your VODs will be muted. Oh shit, really? I didn't even know the VODs are muted. Alright, well, we'll leave this for now. Lo-fi is fine, I think. Okay, so hear me out. I want to know what you guys think here, right? The way I keep track of the duplicates, obviously we have our count, right? The way I keep track of the duplicates, would a set work? Right? We use a hashy here. We move our right pointer, right? And we add each value to our set. Once we see a value that's already in our set, we increase our count by 1. No, that wouldn't work because we're keeping track of adjacent elements, so that wouldn't work. Yeah, that's stupid of me. That would not work because we're keeping track of adjacent elements, right? So, right, we're keeping track of adjacent elements, right? That's the whole point of this problem. Find the longest semi-repetitive substring. Adjacent same pairs of 1, 1, and 8, 8. We need to think of a way. Music is louder than your voice. Oh shit. Okay, I turned it down a bit. There you go. Hopefully that's better. My bad. So we need to think of a way that we can keep track of these duplicates, right? Or how can we keep track of an adjacent values? Well, I'm not sure. Honestly, I'm kind of stuck. It's been a while since I've implemented a sliding window. If you wanted to avoid any sort of copyright contention, play Epidemic Chill Beats. I'll take a look. Epidemic Chill Beats. Okay. What do you guys think, Galactic or Ethan? What do you think here? What is? I'm honestly not sure. What is the best way of keeping track of the duplicates, right? Well, the best way, the only way that I can possibly think, which I think is probably wrong, is if our left pointer is different to our right? So in this case here, we start our left pointer here and our right pointer here. You know, they're the same. We move our right 1, and we will compare. Well, is left equal to right? No, it's not. Then we move our left value here, right? And then we increase our right over here. They're the same. We know this is adjacent, right? This will go to 1. Okay, we move our right over here. See, they're different. Move our left by 1. Or move our left. No. Not move our left by 1. Boolean, because you only need to know if you already have found a duplicate. Okay, that would work too. But I'm saying, how would we identify if we found a duplicate here, right? Is this the correct way you think that I'm thinking about it? That if we use our left and our right pointer, so in this case we would move right here, right? So right, I'm gonna get rid of this R here. Right would now be here. Okay. We compare, they're not equal, right? So then we would move our left to our right, and then move our right over here, and then we'd see a duplicate here. Well, no, you need a counter. You need to track if you have more than one adjacent duplicate. Okay. Yeah, fuck, that's kind of stupid of me. I should have thought what you guys said. Yeah, S right is equal to S right minus 1. Increment. Okay. Yeah, you guys are right. I think we have the right idea. And then really we're only moving... Okay. I think we have a right idea. Let's just kind of get straight into the code type shit. Oh, what is this problem called, bro? 2730. Okay. 2730. Okay, let's reload all. Okay. Okay. We have our solution here. Okay, so what do we want to do? We want to define our left, right? So our left is equal to 0. Our right, I guess, can be whatever. You just reset the boolean if you find another duplicate, but yeah, integer works too. Okay, so let's loop through, right? We go int right is equal to 0. I is less than the size of the string, s.size plus I. What do we want to do here? Well, we want to initialize our count. We'll use an integer for now. Sorry, Galactic. You're going to take the L, bro. No boolean, no boolean. We're going to use a count, right? Okay, well, obviously it's not I. I fucked up already. Got our right here. We're obviously gonna, what are we gonna return here? We're gonna return, I think, our right minus left plus 1, right? Right is undefined. Shit. I guess we don't even need to. Can we use our right here, bro? Like, what? Hang on. Okay, let's leave this for now. Let's leave this at 0 for now. What do we want to do here? Well, we probably want to check. Okay, well, if S right is equal to type int right is equal to 0 outside of the loop. Right is equal to 0. If S right is equal to S right minus 1, we need parentheses around this shit. If S right is equal to S right minus 1, then what do we want to do here? Well, 1, we would increase our count, right? We know that. We have found a duplicate, right? Trying to think here. We have found the duplicate, right? So what would be the way to go about this? Well, really in this case, what do we got here right now? What is this going to do? Really, we're going to loop, we're going to find our count, and then we're going to loop, and we're going to loop, and we're going to find our count's going to be 2, right? So we need some sort of check, maybe inside of this if, or included in this if and check, well, if and S and count is what we want to check is count is less than 1, right? Because we want at most 1. We can't have any more. And then 4 right plus right. I think that's what I got. But thank you, Ethan. I don't know how long ago you typed that, but because we want to check here that our count is less than 1, right? If our count is not less than 1, then there's no point of even adding it, right? I don't know if this is incorrect, but I was thinking in Python, if I was doing this in Python, I would probably keep track of a max, right? At each iteration. Would we want to do that at the end of every loop? Oh, shit. Okay. We increase our count by 1. Are you... Rise less than size plus right. So is this right? I leave it right like this, right? Or do I leave it blank? Like nothing here. Like this. I think that's what you mean, right? Leave it blank like this. Count is less than 1. We increase our count by 1. Yeah, I could. Yeah, that is true. I could do that, but I'm just gonna work with the for loop because I think it works fine in this case. Yeah. If S right is equal to S right minus 1 and count is less than 1, we add our count, right? But now we get to the point when we see 3, we get to this point in our array. We want pretty much what we need now. The only thing that we're missing here is we need a max function, right? We need to be calculating what we're going to return here after every single iteration when it's valid, right? Dude, I'm kind of blanking out a little bit. Shit, bro. I'm thinking that this is probably wrong here. This part here. Bro, I'm tripping, dude. Check if right is greater than 0 to avoid going out of bounds. Hang on, let me read this. Check if right is greater than 0 to avoid going out of bounds. Don't doubt yourself, bro. Thank you, dude. I appreciate that. You could use an inner loop while we have more than one adjacent duplicate. Move the left pointer. You are right. Take a while. You could use an inner loop. Also check if right is greater than 0. Looks pretty good. Don't doubt yourself, bro. Try an overend squared. Yep. Thank you for that. Yeah, I will. You could use an inner loop while we have more than one adjacent duplicate. So while bounds check. Keep that if statement. That's where I was saying to check if right is greater than 0 and s is equal to right minus 1. Well, you're saying keep this and put a while here. Is that what you're saying? This is what you're saying, right? While you said while right is greater than 0? Is that what you're saying here? The while would operate on a duplicate count. Oh, okay. Where do you say the bounds check? While count is less than or equal to 1, right? Do we need to do a bounds check? Like, if we have... This might be a stupid question, dude. I got no idea, but, like... Why would we need to do a bounds check if we have a for loop right here? So we have our for here. We jump in. We have a while count is less than or equal to 1. This is an infinite loop right now, like... I think I'm overthinking it way too hard, bro. Like, dude, this is why I probably should have done a Python first. Fuck, dude. Trips me out, dude. I'm thinking about too much. Okay, so I think this is the right what we've done so far. We have the for, the while, the if. Is this right, what I've got here in the while? Like, while count is less than or equal to 1. We only want to keep going when our count at most 1. Yeah, so... Yeah, dude. Kind of blanking here, bro. I'm not gonna lie. I think I need to go back to the drawing board, dude. I think I've confused myself, bro. I have to go back to the drawing board. Alright, so we have our left is equal to 0. Okay. Our right being the for loop here, right? Would we want to start from 0 though? I don't know. Thing is, bro, what's really funny is that I used to love sliding window problems, dude. But now I'm kind of taking the L on this one. Trying to think here. Oh, you messaged me, Ethan. You said if right is greater than 0 and S right is equal to S right minus 1. Oh, bro. That's what it was, dude. It was the... Fuck, dude. That kind of pissed me off a little bit. S right is equal to S right minus 1. We increase, right? So count plus plus. Right, dude. So this here was for the left pointer, dude. I think that's where it was fucking with me, dude. I wasn't getting the intuition here. This was for the left pointer. So while our count is greater than 1, okay, while our count is, if we have more than 1 adjacent, we move the left pointer. We're not keeping it consistent with the entire time. Yeah, bro. I don't know. That kind of frustrates me that I didn't see that. Okay, so we're checking our values here, right? So our left starts here. Our right goes here. We loop, right? We loop. Okay. Our right is now here. We increase our count by 1, right? So our count is 1. We don't move our right pointer. We don't move the left pointer yet, right? Because we don't need to, right? We will go to the next value. We go to the next value here, right? So our right is now here. So we have a length of 4 here. And once we have a length of 4, we want to increase our max here, right? So I'm going to say if I was thinking about this in Python here, right, I would just do max length is equal to max length right minus left plus 1, right? I assume now that I'm using C++, so I'm going to have to implement this by itself. There's obviously no max function, right? I'm going to leave that there for now, right? To deal with the left pointer here, if we're taking the max after every iteration, we get to the end here, we get another count here, right? Oh shit, they do have that. Okay. STD max. Oh, perfect. Okay. Well, that works out. What do we want to do when we get here? Well, we get to the end and we increment our count, right? If our count gets to 1, if it's greater than 1, then we need to deal with that, right? So we would do, well, if S right is equal to S right minus 1, we want to decrease our count. Count minus minus. And then move our left pointer. Left is equal to in this case here, we'd be sitting here. So I guess we'd move our left to our right. Left is equal to right. You want to be checking the left here, not the right this time. Why would we be checking the left here? Oh, okay. Wait, I have an idea. Okay, yeah, I think I understand, right? While our count is greater than 1, we do... I think I understand what you're trying to say. Hang on. Plus 1, right? I'm going to switch color here. So our left is currently pointing to this value, right? We want to check if our left is this one, which it's not. We would do count minus minus. While our count is greater than 1, if S left is equal to S left plus 1, which it's not, then we move our left, right? So now our left is here. We check S left is equal to S left plus 1. We would decrease our count. Count minus minus, right? And then increase our left over here, right? And this would be our new starting value, right? Because this would be our new substring. Yes, nice. Just make sure to move the plus 1 inside the subscript operator. Oh shit, yeah. Thanks for that, dude. I didn't notice that. Right, that's why. Okay, that was a good catch, yeah. I was thinking this would be right, and we'd be moving all the way over here, but then that would defeat the purpose of it being a substring, right? So that's why we're moving the left pointer. You just need your balance check for the left statement. What? I guess we'd have to check if left is greater than 0. I guess I'm gonna go with that. Let's put a breakpoint in so we can kind of chirp the debugger a little bit. Fuck, which one are we doing? This one, right? We have an if here. Floor size. It's equal here. We count. We enter our while. It's going to skip this. We update our max length. We get 3. We have our 4 here. We check. It's not greater than count. We update our max length. We got 4. Now we're going to get to our number 5 here. Oh no, sorry, we're at 4 right now. Oh, sorry, this is where it's going to hit, right? So we check. It is. We're going to increment our count. We see our while here. If our left is greater than 0, which it is, and s left is equal to s left plus 1, increase our left. That's right. We check here. Left plus 1. We exit our loop. We return 5. Well, you're using +1, so you can go past the max length of the container. Oh, okay. Left is less than the s dot size minus 1. Is that what you're saying, Ethan? I assume. Less than the size minus 1. Well, if our left is here, would it be minus 2? Let me see. I think it should pass these test cases, right? I would assume. Oh. Okay, these ones pass. But does it actually pass in terms of the Leetcode test cases? Let's take a look. Oh, this is Python, dude. Shit. I have a feeling, I don't know what it is, dude, but I have a feeling this is not gonna pass. I don't know. Oh shit, I'm not returning MX. I have a weird feeling this is not gonna pass. I don't know why. I feel like I fucked something. Oh, there you go. Okay, it passed. I would write left +1 as less than size, s.size. Why would you write left +1 as less than size? I guess that is the same thing technically, right? I guess it is the same thing. But okay, we've been gone for a little while. I think I'm gonna end the stream there. Thank you guys for watching me struggle. It was fun. It was a good day. Episode 160. My birthday today. It's more clear based on what you're actually doing. Okay, sweet. Thank you, Ethan. Yeah, it was a good day. Good birthday. I was feeling sick a little early. I would have streamed a little earlier, but I've been feeling sick most of the day. I feel like probably because I've been eating fucking donuts and eating like shit all day. So, and I didn't fucking hit the gym this morning, so kind of pissed about that. I slept in. I was fucking too tired. Waking up at 5 a.m. It was AIDS, but yeah, appreciate it. Thank you guys for watching, and we'll see you guys tomorrow. Peace.